nursery was started by my parents back in 1952. Grew up on the nursery, and as the story goes, swore I'd never do it, but as it turns out, here I am. We were primarily at another location in terms of the nursery at that point when I got out of college, and we've expanded it, Lord knows, perhaps 50 or 100-fold since that time. We purchased this farm back in 1988, and a few short years after that, we decided to introduce container production on this field. But before we did that, we realized that we would have additional irrigation issues to deal with, and we wanted to make sure that we were dealing with runoff. Rather than just setting up the container operation, one of our first steps was to put in this tailwater recovery system. Well, once we had that, we had to figure out what we were going to do with the water, and our intention was to recycle that. And at that time, there weren't a lot of choices, but one of the main systems that was available was chlorination. This is a very simple system. It's a very low investment type system, and it proves to be very cost effective. Back then, it was essentially the only option available, and even as time's gone on and other systems and options are available today, we still find from our perspective that this works out to be the best for us in terms of effectiveness, investment cost, operating costs, etc. We have this unit here which services this diesel pump on this side of our retention basin. We have a mirror image across the way, and that has a set of 3 tanks just like this does. Again, this is predominantly a vacuum system. We have a manifold that is fed by these 3 tanks of chlorine. They're 150-pound cylinders. And this regulator basically determines how much flow comes out of this system and works its way into the irrigation water. And how this all works essentially is that we're on the pressure side of the pump as where I stand now, and water is taken off of the pressure side of the main, comes up through this pipe. There's a very simple Venturi type ejector, as they call it, that creates a vacuum and draws in the chlorine. The amount of chlorine that's actually drawn in is determined by this regulator and what setting we have on that. That hypochlorinated water continues down to the end of the suction line. It's discharged at the end of the suction line, and as the pump is drawing up the water, it mixes as it comes up. That chlorinated water then goes through our system, goes through a series of L's and so forth, and then out to our polyhouses where we're growing crop. Some of our polyhouses are very close to this tailwater recovery basin and to this injection system. So we need to make sure that for the 15 or 20 seconds of dwell time that we might have, that we're doing an effective job of disinfecting the water. So as a consequence, we're looking for an instantaneous action on the part of the chlorine. So we go with a little higher level in order to achieve that. So we have the amount of chlorination that we need to disinfect the water, and again, we end up recycling the water, but we don't recycle any disease issues. This is a very basic system that we went with back in that time. Essentially what was available to us. It's served us well over the course of the nearly 20 years that we've had it. We will be moving to another system in the near future, which we'll talk about in a few minutes. But for now, as far as this goes, this probably, thinking back, involved about a $5,000 investment. And our annual maintenance costs are very little. The main thing we have is the chlorine cylinders and getting replacements for those. Currently, the price on a 150-pound cylinder is around $200 some, and we change these for our pumping capacity. We'll probably put 2 new cylinders on this side each week and 2 on the other side each week. In terms of cost, that probably works out to around 10 to 15 cents per 1,000 gallons in terms of actual chlorination costs on an ongoing basis. So in our circumstance, we're treating the water as we pump it. And essentially what happens, as I mentioned before, but what we're also going to be able to do is, rather than treat the water as we pump, we're looking to treat the water as we transfer it from this primary tailwater recovery basin over to our new recycle basin. And by doing it as we transfer, and because we have it then in a holding area, we can cut back on our injection rate because we have considerably longer dwell time. It's going to be sitting in that new basin for an extended period of time, much like a swimming pool, so it has greater time for reaction and to actually disinfect the water. Here we are with our new system. Again, we're in the midst of construction, so it's certainly not a finished product, but it'll give you a little bit of an idea. And to help explain that, I'd like to introduce Lee Fiocchi from Lee Rain.
This system, the type of system it is, the gas chlorination is exactly the same as what he's had over here. The new system has the higher level of safety built in, but it's also a variable rate system, which means we will be monitoring, we'll have an ORP sensor which actually will be monitoring the levels in the water as it's being pumped over, and be adjusting on the fly, adjusting the rate according to how much chlorine to inject into the water. So how this is working is like Ed explained. You can see up top is the manifold, all driven by the vacuum on this side. Each tank has its own regulator on it, so each tank will be pulling in exactly what it's needed based upon the vacuum. This water will be being pumped from this transfer pond and getting transferred over to this pond, which will have a longer dwell time than what is currently happening. So that'll be also an added benefit for making sure that those that bacteria and pathogens are well taken care of by them. You can see here's the vacuum of the chlorination gas. We have a little booster pump on that side, which helps us because of the flow rate and the rate that we need, helps us build pressure on either side to create the vacuum. We'll be the chlorine gas will come in and be injected right into the water source as you see here, and then we'll be getting pumped through across to the other side. So it's going to be a higher efficiency type system, and it's a variable rate system. So you know, with that, Ed's anticipating a better return on investment with this type system because it's going to be more efficient use.
ORP is going to be the measure that drives this automated system, as opposed to free chlorine that we used to measure in setting up this system, which is again more manual and less investment than this, which is more automated and a little bit more in terms of cost. By growing plants in containers, it involves more irrigation. And when we have more irrigation, then we have the potential for more runoff. We just wanted to address that issue. You know, we wanted to do the right thing to take care of that, and at the same time be proactive, because we just figured eventually, as with other states, the government would begin regulating that. So our preference was to deal with the issue up front, deal with it on our terms, so that we have maximum effect of the chlorine, we have maximum effect of the fertilizer, without one diminishing the other. I think there's a tremendous cost savings, because in recycling this water, rather than drawing it from a well and the added horsepower to bring it to the surface, and again, the initial water is supplied by wells, and this water is supplemented by well water, but the fact that we're recycling all the runoff means we're taking water that's at essentially surface level and repumping it and reusing it at far less horsepower requirements than it would be if we drew everything from a well. But we've created a reservoir that we can draw from and pump a considerable rate of water at any given time. So for other folks who might be in a similar circumstance, it's a great source of water. It saves in terms of energy cost to actually pump it, and so there are cost advantages along with it. With our irrigation system currently, we filter as we come out the, there's a filter over there, so before it actually goes into our irrigation main, it is filtered by a 200 mesh screen filter system. So what we're currently doing on the discharge side in terms of filtration, we will be doing at time of transfer on the suction line end of it. So the water that's coming up here will be filtered down to 200 mesh, which will help reduce some of the load. And then we'll be pumping over into these basins that are lined with polypropylene liners, So that's going to be a pretty clean environment. Here, this tailwater recovery basin, of course, draws in rainwater, but this is isolated and out of the flow of stormwater runoff that we really don't expect any problems with water going in there. We've had some pretty tough storms over the last few years, and we've designed this so it meets that test of being removed enough from that. Again, there's a certain peace of mind and a certain degree of controlling your own destiny by being proactive, and that's our preferred options.